Welcome to The Explainer. Today we're breaking down some fundamental chemistry concepts, and we're jumping right in. Have you ever really stopped to think what makes a shiny piece of gold so totally different from a dull lump of coal? Well, we're about to demystify some of chemistry's most basic building blocks.
Okay, so let's kick things off with a really simple but super important question. What's the real difference between a metal and a nonmetal? It seems pretty basic, but, understanding this is basically the first step to understanding, well, just about everything around us. So, we're going to tackle this fundamental division between metals and nonmetals, and we'll do it by looking at them in two key ways. First, we'll check out their physical properties, the stuff you can actually see and touch. And then, we'll get into their chemical properties.
First up, physical properties. This is all about the characteristics we can observe directly, how they look, how they feel, and just how they behave in the real world. And check this out. Our source material lays it all out for us in this great side-by-side comparison. So let's just walk through the most important points one by one.
So the first thing you notice right off the bat is just their appearance. Metals have that distinct shine, that luster, think of polished silver. Nonmetals, on the other hand, are usually pretty dull, kind of like a piece of charcoal.
Next up is conductivity, and this one is a really big deal. Metals are fantastic conductors of both heat and electricity. There's a reason our electrical wiring is made of copper, right? Nonmetals are the exact opposite. They're poor conductors, which actually makes them great insulators. Now let's talk about strength. Most metals are hard and strong. You can bend them, you can hammer them into different shapes, and they won't just break. Nonmetals, though, tend to be either soft or brittle. If you hit one, it's much more likely to just shatter.
And here's a fascinating property you might not think about: sonority. It's a fancy word, but the idea is simple. When you strike a metal, it rings. This is exactly why things like bells and cymbals are made from metal, not something like plastic. Makes sense, right?
All right, so we've covered the physical side. Now let's get into their chemical properties. This is all about how these substances actually react and interact with other elements.
Here's a classic chemistry lab test for you. What happens if you drop them in some acid? Well, in active metal, something like zinc, it'll start to fizz and release hydrogen gas. A nonmetal, though, it'll generally just sit there and do nothing. It's a very clear chemical dividing line.
But if we get down to the atomic level, this is the most fundamental difference of all. Think of it like this. Metals are givers. They tend to lose electrons, which makes them become positively charged ions. Nonmetals, they're takers. They tend to gain electrons, becoming negatively charged. And honestly, this one single behavior dictates almost all of chemical bonding.
So we've seen how elements differ. Now let's use that same comparative approach to look at compounds, specifically in inorganic chemistry. We're going to shift gears a bit and focus on the difference between what we call saturated and unsaturated compounds.
And as this table from our source shows, the key difference really just comes down to one thing: the type of bond that exists between the carbon atoms. And believe me, that one single difference changes everything about how these compounds react.
So, what is a saturated compound? Just think of the word saturated as meaning completely full. In these compounds, the carbon atoms are holding on to as many hydrogen atoms as they possibly can. They're all connected to each other with these simple, stable, single bonds. And all that stability makes them relatively unreactive.
In contrast, you have unsaturated compounds. These guys have at least one double or even a triple bond between their carbon atoms. Now, these bonds are kind of like coiled springs. They hold a lot more energy, and they're much more willing to break open and react with other atoms. And that's what makes them far more chemically reactive.
So let's just boil this all down, shall we? The difference between metals and nonmetals really comes down to their shine, their conductivity, and whether they give or take electrons. And for carbon compounds, it's all about the bonds. Stable single bonds mean it's saturated, while those more energetic double or triple bonds mean it's unsaturated and ready to react.
And that leaves us with one final, bigger question to think about. We've just gone over some pretty simple rules. Metals give electrons, nonmetals take them. Some carbon bonds are stable, others are reactive. So how do these incredibly basic principles build literally everything around us, from the steel in our buildings to the plastics in our pockets? Well, it all starts right here.